Today, the Royal Navy, once the undisputed master of the seas, is facing a crisis that few dare to speak about openly. In this audit, we dissect the structural, financial, and operational decline of one of the world's most legendary navies. From manpower shortages to engineering disasters, and from budget battles to a shrinking global presence.
The structural decline of the UK Royal Navy is fundamentally driven by a persistent crisis of human capital. For over a decade, the recruitment and retention of regular personnel, officers, and highly specialized technical ratings have faced significant operational bottlenecks. While recent defense metrics indicate a stabilizing influx of new recruits due to shifting domestic economic conditions, the structural damage to the older pipeline remains visible. This prolonged deficit in trained strength continues to compromise the fleet foundational capacity to generate enough personnel to sustain regular global deployments simultaneously. This historical recruitment deficit is compounded by a severe retention crisis within critical technical branches, most notably marine and nuclear engineering. Highly trained technicians are leaving the service at notable rates due to continuous operational overstretch and unstable deployment schedules. To mitigate these immediate gaps, the Navy has frequently resorted to the disruptive practice of cross-decking personnel between alongside units and active platforms. This temporary fix accelerates professional burnout among senior ratings, disrupts critical on-the-job training for junior sailors, and encourages experienced personnel to transition into the civilian sector. The resulting manpower shortage has forced the Naval Command into aggressive crew harvesting, which involves the premature retirement of certain surface combatants. Selected legacy hulls have been decommissioned ahead of schedule simply to free up existing crew pools for incoming next-generation platforms like the Type 26 and Type 31 frigates. This emergency measure represents an inefficient use of past capital expenditure, as recently upgraded vessels are effectively sacrificed to sustain basic staffing requirements. Furthermore, this labor crisis has extended into the civilian-staffed Royal Fleet Auxiliary, where ongoing industrial disputes over pay and grueling conditions have limited the availability of active logistical support ships. The operational availability of the Royal Navy capital ships remains restricted by persistent mechanical challenges and complex engineering flaws. The physical symbols of British naval power projection, the Queen Elizabeth-class aircraft carriers, have suffered major and highly public propulsion train breakdowns. Specific manufacturing defects within the massive propeller shaft couplings forced prominent flagship deployments to be abruptly cancelled or reassigned. Repairing these oversized components requires long periods of dry docking at facilities like Rosyth, which temporarily removes the nation's primary strike assets from the global theater. Simultaneously, the air defense capability of the surface fleet has been undermined by the complex propulsion architecture of the daring-class Type 45 destroyers. The original integrated full-electric propulsion system features a major design flaw within its intercooler units when operating in warm water environments. In regions like the Persian Gulf, the system struggles to shed heat efficiently, resulting in significant power generation failures that heavily degrade the ship combat systems. Although the extensive power improvement project was launched to install more resilient MTU diesel generators, the physical modifications require cutting open ship hulls, creating a massive maintenance backlog that slows down the class return to active service. These engineering crises are worsened by a critical shortage of spare parts and limited domestic maintenance infrastructure. The Ministry of Defense has frequently relied on equipment cannibalization, traditionally known as stores robbing, to keep deploying platforms functional at sea. Components are routinely stripped from submarines and ships still in production, which damages engineering morale and introduces secondary technical risks across the fleet. This cascading maintenance crisis is amplified by severe backlogs at key domestic naval dockyards, which lack the specialized technicians and dry dock availability necessary to service the nuclear-powered submarine fleet and surface escorts efficiently. The surface fleet faces a distinct lethality deficit characterized by a quantitative contraction and a multi-year transition gap in offensive strike systems. The active frigate and destroyer escorts have shrunk to historically low numbers, leaving the Navy struggling to meet standard maritime security commitments independently. Standing tasks like shadowing foreign naval transits through home waters are increasingly rotated or delegated to offshore patrol vessels. This persistent escort shortage has effectively forced a significant reduction in British surface combatant presence in strategically vital regions like the Middle East. Offensively, the retirement of legacy anti-ship missiles left the surface fleet without a long-range heavy-duty surface-to-surface weapon for a notable period. While the interim Norwegian-built naval strike missile has been procured to plug this capability gap, its technical integration across the remaining fleet is still a work in progress. The permanent supersonic and subsonic replacements under the joint Anglo-French Future Cruise anti-ship weapon program face highly compressed development timelines. This leaves British surface combatants operating within a narrow offensive envelope for the remainder of the decade as they wait for full system integration. This design compromise is also visible in the incoming Type 31 general-purpose frigates, which were built to strict cost ceilings that delayed the immediate installation of heavy missile cells. While the underlying Arrowhead 140 design structurally allocates space for the Mark 41 vertical launch system, the phased procurement of advanced strike missiles means initial hulls will enter service underarmed. Because of this widespread escort and missile deficit, the Royal Navy frequently relies on international allies to deploy a doctrinally complete carrier strike group. The Navy routinely integrates Allied destroyers, anti-submarine frigates, and foreign auxiliary ships to sustain its global carrier operations. The operational decline of the fleet is driven by a deep structural disconnect between expansive geopolitical ambitions and fiscal realities. The government's strategic framework demands a persistent global maritime presence, yet the actual defense budget remains highly vulnerable to inflationary erosion. Recent funding uplifts are heavily diluted by reallocated capital budgets and unconfirmed financial commitments that leave notable fiscal gaps. This budgetary strain makes it difficult for the Ministry of Defense to properly fund both its immediate strategic commitments and conventional fleet recapitalization simultaneously. The primary driver of this intense financial pressure is the mandatory prioritization of the strategic nuclear deterrent within the ring-fenced defense nuclear enterprise. Massive capital expenditure is currently consumed by the construction of next-generation Dreadnought-class ballistic missile submarines and the ambitious SSN-AUKUS attack submarine program. These high-priority nuclear projects suffer from severe procurement cost overruns and extreme sensitivity to international currency volatility. This concentration of capital systematically starves the conventional surface fleet of resources, directly resulting in the delay or scaling back of planned future frigate programs. This funding starvation has simultaneously impacted the vital logistical auxiliary fleet, which acts as the operational backbone for any sustained blue water deployment. Multiple fast fleet tankers have been retired early or placed in extended uncrewed reserve due to a lack of maintenance funding and available civilian personnel. The construction of new fleet solid support ships faces delivery timelines that extend into the next decade, creating a critical multi-year logistical gap for dry stores and ammunition. Without these crucial auxiliary vessels, any deployed British task group faces limits on independent long-range operations and must rely on foreign supply networks. The quantitative and qualitative contraction of the fleet has reshaped British maritime strategy, forcing a deliberate consolidation toward its core theatre. Along NATO's vital northern flank, sustaining fully independent carrier task groups has become unsustainable, leading to deeper bilateral integration, most notably with Norway through the Joint Expeditionary Force framework to monitor Russian submarine transit across the WWII gap. Analysts note, however, that while this cooperation strengthens deterrence, it still leaves a capability gap in the High North, where protection of undersea cables and energy infrastructure requires persistent, sovereign presence that the current fleet struggles to provide. Beyond the North Atlantic, the era of routine unilateral global deployments has effectively ended. Carrier strike deployments remain powerful political signals, but their operational credibility now depends on embedded Allied escorts, as demonstrated in CSG-21 with US and Dutch destroyers. This is not a failure of seamanship, but a reflection of reduced mass. With only 6 Type 45 and a shrinking frigate force, the Royal Navy has prioritized NATO and home waters over permanent Indo-Pacific presence. The delay of the Type 83 destroyer and the fitted for but not with approach on Type 31 formalized this shift from a blue water navy to a regional power with expeditionary reach. In response, the Royal Navy is pursuing one of the most ambitious unmanned transitions in NATO, the hybrid fleet concept. Rather than a desperate gamble, this is a necessity-driven pivot led by NavyX. Platforms like the XV Patrick Blackett, Mad Fox, and Cetus XLUUV are already conducting operational trials, not theory, aiming to restore mass through a treatable USV and UUV controlled from lean crewed motherships like the future Type 32. The risk is not the technology itself, but the timeline. The Royal Navy is retiring crewed hulls faster than autonomous systems are proven at scale, and its procurement history offers little confidence in rapid delivery. If executed, this model could redefine maritime power for a mid-size navy. If delayed, it risks institutionalizing the very capability gap it was designed to solve.